Hello, we're Team S.Q.W.R.T.L.E, which stands for Sustainable Quality Water for Turtles. I'm Paikea, and I'm a first-year civil engineering major.
My name is Jonathan. I'm a first-year mechanical engineering major.
My name is Megan. I'm a first-year civil engineering major.
And I'm Matthew. I'm a first-year biological systems engineering major, and we're all students at UC Davis. Now Megan will explain our problem.
Saving the turtles is going to take a lot more than switching to reusable straws. Increasing drought conditions have effectively weakened the stability of the inland waterway food chains, jeopardizing the already threatened western pond turtle species. During extended periods of drought, phytoplankton populations can decrease from 500,000 to just 35,000 per cubic meter of water. Since phytoplankton are the foundation of the entire ecosystem's food chain, we designed a solution to help the turtles and their entire community by resupplying phytoplankton into the environment, specifically in the Suisun Marsh, an essential subenvironment in the Sac Delta. Jonathan will explain further.
Thank you, Megan. Our intended users are conservationists and organizations such as the National Park Service, the Wildlife Heritage Foundation, and the U.S. Fish and Wildlife Service. As Megan said, our design solution focuses on the Suisun Marsh because during peak drought conditions in summer months, for instance, the pH of the Suisun Marsh would lower, and this would kill phytoplankton and kill higher orders in the food web, including the western pond turtle. We wanted to address this with an innovative solution that can aid turtles while having a minimal impact on the homeostasis of the environment. And with that, Matthew will now explain our design process.
Thank you, John. The design process. The most challenging part of our project was actually finding evidence supporting the western pond turtle's reliance on phytoplankton. So we went through the iterative design process, and here you can see our initial sketches and how that eventually became a cardboard model and then a CAD design. We had to make some final revisions. Originally, we were going to have our device release manure into the Suisun Marsh, but we didn't want to do that because we didn't want to disrupt the homeostasis. Instead, we're going to release phytoplankton. We had an option to use a solenoid valve, but we couldn't do that because we didn't have a pressure differential. Instead, we're going to use a scooping mechanism with a servo motor. In the future, we want to make our final product not out of cheap materials such as cardboard and or foam core. Instead, we want a device that can actually float and that we can test the buoyancy with weights. We want to have some kind of mesh to protect the phytoplankton tank from the outside elements and to have some way to monitor the phytoplankton inside. And now Megan will talk about our testing results.
Through our testing, which we measured in two different ways, first through the weighted mass difference of paper towels, and then by measuring the catapulted water from a bucket using tablespoons, we're able to find that the catapult does in fact work and is able to launch roughly 0.8 tablespoons of water, which doesn't sound like a lot, but in reality, our device would be scaled much larger, and this catapult would potentially be able to hold up to 0.011 cubic meters of water, which would hold about 4 million phytoplankton per launch. Paikea will go over our prototype.
Thank you, Megan. In the center of our current prototype is the phytoplankton tank. Above it is our main feature, the catapult arm connected to a servo motor. The servo motor will launch phytoplankton into the marsh when our pH sensor senses a pH of less than 7.75, a clear indication of drought. Unfortunately, we did not have access to a pH sensor, so to simulate that, there's a light sensor that triggers the catapult when the sensor is covered. S.Q.W.R.T.L.E can change the Suisun Marsh ecosystem from dying to thriving through automated plankton release. All we need is your support. Thank you.